All right, for about work, you got 2 problems. I'll give you 3 minutes and then we'll go over it. Nope. Okay, let's go over it. So to rewrite this as a exponential, you really just need to look at that thing that I said is like super important. You should tattoo it somewhere. And it was really funny and you all laughed, right? If this is, again, it doesn't really matter what the letters are, but if you say that this is a, x, and y, then the log base a of x equals y, if and only if a to the y is x. So if we rewrite this in this form, for us, our a value is 3, our y value is 4, and our x value is 81, which should make sense because 3 to the 4th is 81, right? One of the nice things about this is after you write it, you're pretty sure if you did it correct or not, because it should be a valid equation, right? If you write 81 to the 3 equals 4, you know you messed up. Yeah? Yeah. All right, number 2, we need to find the domain of this function. Does anyone remember how I start that? What do I need to write? It's very close. We don't say equal to 0. U greater than 0. That's right. To solve this for x is 2 steps. Add 10. And divide. Do I need to flip the sign this time?
No.
Why not? It is not negative. It's a positive number. So you could tell me that's 5.5 or 2.5 either. So then how you would write that in interval notation is x has to be any number between 5 halves and positive infinity. Not including 5 halves and not including infinity, which is why we put brackets on both of those. In parentheses. Who said brackets? Yeah, whoever that was, that person is a prankster. Yeah. If you plug in 0, you will get 4 times 0 minus 10, which is negative 10. And you can't take the logarithm of negative 10. Like 1? That's right, yes. It's good to test. As another way also is really just to test values. If you're not sure at the end you got this right, plug in the number and see if you can do it. Right? Does 1 actually work? 4 times 1 would be 4. 4 minus 10 is negative 6. Try in your calculator, log of negative 6. It'll tell you error. All right, questions on the board? Anybody need more time to write? Okay, today we do properties of logarithms. The first thing is something we already did, the different base rule. We already did that. So that'll go by really quick. Rewriting expressions, expanding or condensing are really the same thing. That isn't so bad as long as you pay attention. If you pay attention to what's going on when we go over that, you'll be okay. If not, it will look like it's written in a different language. In the middle of class? Possibly. And then we won't even cover this last one. That's just application problems. I don't even think I put one on here. Let's see. Do that. That. Wait, what is this? Why is this here? We already did that. Why is this included in the slides? I think I forgot to delete those. This is the last slide. Hold on. I'll delete it later. So it's really how many slides? It's really 9 slides we have to do. Yeah, we could take a break. Or I guess I'll just leave it up to you. Okay, here's the first thing. First thing I told you is something we actually already did in class already. If your logarithm is written as log base a of x, you can change that base of a to any number you want by doing log base of whatever number you want of the value x over the log of the base. The most common time and use for changing bases is to get it into base 10 and base e, because those are the ones your calculator can do really quickly because it's got the buttons for base 10 and base e on your front of your calculator. In which case you just do log of the value divided by log of the base, or the natural log of your value divided by the natural log of your base. We did that yesterday or Monday. Anybody need more time on this? I'm holding up. Huh? Do you want to see an example?
Yeah.
Let's do an example. So for example, see if you can type both of those into your calculator. Yeah, just type it into your calculator. See if you can do those. I'll give you 1 minute. The answer should be between 2 and 3. Let me show you how to type it in. All right, so there are 2 ways you type that in. Stop share, reshare, full screen. All right, so one is to use the change of base rule. We'll just do log of our value, 25, divided by log of the base. 2.322. Or if you fancy yourself a sophisticated individual, you can do the natural log of 25 divided by the natural log. Same answer. Or if you're a fancy pants, you go math and then down to option A. Not all calculators have that. You have to have a newest version. If yours doesn't, I can update your calculator so it does. But if you do that, then it'll just let you type in the boxes. 4, 25, 2.322. So for B, again, you could do log of 17 divided by log of 3 to get the answer 2.79, 2.579. Or you would get the same answer if you did the natural log of 17 divided by the natural log of 3. Or you would get the same answer by hitting math and doing option A. Log base 3 of 17. You need to learn one of those 3 ways of doing it. Yeah?
Never mind.
There's no stupid questions.
Okay, well then. Is log base 10
Yes.
natural log?
No. Log, the first one, log, that's log base 10.
Yeah.
The ln, the natural log, is log base E.
But oh,
That's this. Math A log based E of 17 is the natural log of 17.
never mind. See, I thought it was.
No, that's a great question.
Okay.
Yeah, no, there's so many people who will mess that up on the test. Log base E is natural log. Those are the same thing. Log without a base written is log base 10. Log base 10 of 17. Yeah. Same thing. Okay. All right. We feel okay about change of base rule, which is basically used to type this stuff into the calculator. You think you could type one of these in your calculator on the old website? Little test reading, little Quizinator, ACT. Okay. Then next thing we're going to do is the properties of logarithms, and there are 3 of them that you need. The first is the product rule. The product rule states that if you have a log of u times v, that is the same as the log of u plus the log of v. Same thing for natural logs. The quotient rule states that if you have the log of u divided by v, That's the same as the log of u minus the log of v. And the power rule is the one that you will mess up the most. The power rule says that if you have log of u to the power of n, that's the same as n times the log of u. These rules are pretty much the exact same as the rules you did for exponents. If you have x to the a times x to the b, what do you do with a and b? You add them. If you add x to the a divided by x to the b, what do you do with a and b? Subtract them. If you had x to the a to the power of b, what do you do with a and b? You multiply them. It's the same rules. If you have two things multiplied, it's addition. Divide, subtraction. A power, multiply. It's the same rules as you had for exponents, just in a different notation for logarithms. I actually don't think we're gonna, I think our break, after the break will be time for you to work on homework because we're almost done with this. We just have 3 types of problems to do and then we're done. No problem. Unless you want to take a break right now. But that'd be silly. What silly goose would want to take a break right now?
Super silly.
All right, anybody need more time to write? All right, here are the 3 types of problems you'll see on website. First, to verify that one log is the same as another. Show that negative log of 10 base 10 of 1 over 100 is the log base 10 of 100. We're going to do that by first rewriting this value as a power. 1 over 100 is the same as 10 to the negative second. Okay, everyone okay with that conversion? 10 to the second is 100. Negative powers make your value go in the denominator of a fraction. All right, so then this becomes negative log base 10 of 1 over 100 is equal to negative log base 10 of 10 to the negative second. And then we're going to do the power rule. What can I do with this power? Wait, why did I do negative second? Mr. Lake, you silly gooseball. This is supposed to be 100, not 10. Why did they do that? Ah, whatever. This is so boring. Okay, there we go. Fine. Is that better? Is everyone happy with that? This is the worst. All right, whatever. That is probably easier to see, right? 100 to the negative first is the same as 1 over 100. Right, because negative powers just put your value in the denominator of a fraction under what? It's a reciprocal. Okay, now we're going to do the power rule. If I have a power of a logarithm, what can I do with that power? You multiply. What is negative 1 times 1 times negative 1? It's just positive 1. And hey, look, that's the value I was supposed to get. So you could show those logarithms are the same in 2 steps. 1, convert your value into a power. And 2, apply the power rule. Whenever you have a power, you just move it in front and multiply. Yay? You ready to try it?
No. Yeah.
Good. Let's do it. Your turn. I think there's only one of these on website. All right, show that the natural log of e to the fifth is 5. You can do this in 2 steps. First, apply the power rule. Step 2. Maybe 3 steps, depending on how you write. Step 2 is a mystery. I can't really give it away. Evaluate. That's what I'll put. I could say that. I can't say anymore without giving it away. I'll give you more time than you need to work on this. 1 minute. Does it really take up 2 pages? Why did this have to take up 2 pages? Oh, because of the solutions are super gross. It's a pretty tree out there right now. The yellow one. It's got some good leaves going. I don't know if you can see it from here, that back window. When you walk into class, you see that tree there. Good tree. I really, it's not bad. There's some dogs that usually come out over there. There's chickens over there.
Chicken.
Yeah, there's chickens over there. I actually don't know. I haven't heard them in so long. Maybe there's not chickens there anymore.
The dogs.
It's possible. It's possible. All right, if we use the power rule, what do I take with, what do I do to this power? Move it in front. What is the natural log of e?
One.
1.
Wow.
What's 5 times 1? 5. Because remember, the natural log of e is log base e of e. So you're asking yourself, e to the what power is e? What do you have to raise e to get e? 1. E to the first power is e.
What's the natural log?
There. Is in the instructions.
Oh, I thought that said in.
Does it just say n on yours?
No, like in. Like
Ah.
verifying that in. E.
It should be ln. Does it not say ln on yours?
No, it does.
Okay. Okay. Okay.
Resistance.
Got it. I got it. All right. Yay. There's one of those on WebAssign. This is the more popular problem you'll see on the old WebAssign. I'm waiting.
No, you are, okay. No, what's.
Yay.
No.
Okay.
What are you making there, Mr.?
I'm going to show you what the pair is painting. The pair is painting a star. The pair likes stars.
Yeah, I got that.
I like the sticker feature.
Oh, now he's yellow.
Are you ready for the next slide or? Yeah? You ready? Next slide. Okay, next slide.
He's a gold star.
All right, next slide. Use the property of algorithms to expand each expression. So if we're going to expand each expression, the first thing we're going to use is the product rule. I have 5 times x cubed times y. According to the product rule, if you have a logarithm of u times v, you can expand that into a logarithm of u plus a logarithm of v. So this will become, first step, log base 4 of 5 plus log base 4 of x cubed plus log base 4 of y. Yay? Again, if you have a logarithm where stuff is being multiplied together, you can expand it by putting them as separate logarithms that are added together. That's the product rule. All right, step 2 is the power rule. I have 1 power, there's 3. What can I do with that power? Move it in front. So we get log base 4 of 5 plus 3 times log base 4 of x plus log base 4 of y. This is the part where I was saying, if you're paying attention right now, this is not too bad. You're just applying 2 rules. If you're not paying attention and you're just now looking up, you can be pretty intimidated by that screen. It looks like a lot, but in reality, you're just doing 2 things. You're adding plus signs and you're moving a power. There you go, final answer. Okay, let's say that you have learned from your mistakes of not paying attention. Now pay attention that we do the second one. In this case, what we have is not a product, but a quotient. So now you look at your notes, big bang, quotient rule. If I have a quotient, I'm gonna subtract. Right, 2 separate logarithms where I subtract. So I'm going to do this one in blue. This becomes the natural log of the numerator minus the natural log of the denominator. That's the quotient rule. But let me ask you a personal question. What is the square root really? Isn't that really just raised to the half power? Isn't it? Square roots and raising to the half power are the same thing. So then I'm going to take that half power, and you know what I'm going to do to it? I'm going to put it in front. When in doubt, just put it in front. If you're not sure where something's going to go, just put it in front. That's power rule. Good question. Why can't you split it up? Because it's a minus, not a times. If this was 3x times 5, I could split it up. But because there's a minus sign here, I believe we're just done. And we say, good job, us. Pat yourself on the back. Done. If it was just 3x and not 3x minus 5, you could do more. But because it's a minus 5, that is a subtraction, not a product. And you can't do anything to that. Yay? You ready to try it? You excited? All right, your turn. Does anybody need more time to write? Okay. Try this one. 1 minute on the clock. First person to get it done can have the choice to turn the lights on or off, or keep them off. you'll have that power. First person that gets it right gets it first. Gets to choose whether or not the lights stay off or if they can turn them on. If you want the power to be punched in the face, you want to get this right. Okay? I'm so good at motivating people. We need another minute. Okay, one more minute. I'm gonna start the timer over. I'll walk around. You can do one more. Oh, actually, hold on. That makes sense. You don't want that there. That should be like parentheses. Okay. Before you do the power rule, you can split that up. The 4 and the x cubed. And make it log of 4 plus log of x cubed.
It's the square root is the
There's
same.
one more thing. That should be. Well, we should, it is a square root.
Yeah.
Do something to that too. I don't want to see that. Square root. Change that square root to a power.
Oh, I know what you did.
You can, before you do the power rule, do the product. That's 4 times x squared. Don't do the quote. Sure, yeah, I think you heard the whole thing. These are the 3 things. So if you have a division, you'll split it into 2 logarithms. Log of the numerator minus log of the denominator. Log of 4x squared minus log of square root of. He's right. We're just expanding it. Just have some stuff actually going to solve it. That's future class. You do that. Yeah. I mean, it doesn't hurt that. Hey, that's the first question. You want the lights turned on?
Also, just say,
That was your authority. You have the power.
and you have the power to almost get punched in the face.
We can still block. But
Yes.
I kind
No,
of
one
like-
minor thing that I noticed earlier. It's actually a second. Not that that's a big deal.
It's a fight for it. That's good. We learned my plans.
Yeah. That's good. Yeah, 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 you do.
I know she did.
This side is actually how we do it. I'm checking your, Before you do the power, you do the 5. Split the 4 and the x squared. This is 4 times x squared, so turn that to log of 4 plus log of x squared. Yay. Yeah. How are we back to? Good? Good. All right, now do the product rule first. Before we have to say.
You just leave it back.
That should be 4 plus 2. Since the 4 and the x squared are time.
So, okay. Separate the y's and
Yes.
half log
Yes.
plus y or just
Half log of y.
of y.
Yeah, parentheses y.
That's what.
Yes, that's good. That's good. And the half should go in front of that, because that disturbs me. That's where the half should go. All right. Okay, I saw some really good stuff, and I also saw some not so good stuff. So let's go over this. First is the quotient rule. The main thing I have here is a 4x squared divided by square root of y. So I'm going to turn that into 4x squared. Okay, how do you write twos? You write twos like that? Okay, minus log base 3 square root of y. Okay, that's your quotient rule. It's your old quotient. Okay, now before you do the power rule, this is 4 times x squared. It's important that you do the power rule, the product rule first, because the squared is only with the x, not with the 4. So split these with the product rule to get this plus log of x squared minus log square root of y product. Okay, and then the last thing you're going to do is the power rule. And there are actually 2 powers that you can do. This 2 will go in front. And then this square root of y can be rewritten as y to the half power, put that half in front. You got to use all 3 rules for that guided practice. Isn't that cool? Questions? Concerns? Criticisms? Okay. Let's do you want to take a break or do you want to do the last 2 slides?
Great minds, great minds.
Does anybody need more time to write? All right, let's get this over with. I mean, let's cherish every moment of these last few problems we have together. Okay, this is the opposite of what we just did. We have it expanded. We are going to condense it. So, first thing we're going to do is the power rule. Make this a power. Make this a power. If it is okay with you, I'm not going to put the base 10 since that's implied. And I'm also just going to go straight to the square root.
Yeah, whatever gets it over with. I mean, whichever one we share.
You all. It was better when there was 2 different sections of pre-calculus, so I could split all you troublemakers up into 2 classes of like 12 instead of 1 class of 24.
Wow. Imagine second class. That would be great.
Last year for the second class, it was 6 people. So we took some free days to do Bob Ross paintings together. Because there was enough people, I just brought in stuff. We all just did it together. Those all right there. You see the dictionaries? Those 3 left their paintings here for you all to admire.
Well, you see, that's 3 days. You don't
Yeah.
have to paint. Well, like, you could just give us a little bit.
That doesn't make sense. A free day where we don't paint. What's the point of a free day then?
Or like play board
We just
games.
need a free day.
Yeah, doesn't make any sense.
We can play Uno.
We could play board games. That's fair. We should have, it's in the second semester that we have free days. This semester is kind of tight. We actually won't get through everything. We'll have to choose topics.
Let's choose the easy ones. I think we should just throw long out the door, window, whatever.
Or the widow.
The widow, the widow.
It's a choice between, I think, how much probability versus series you want to do.
What does that mean? Which one's easier?
So a series is like, we'll talk to you about the Fibonacci sequence. 1, 1, 3, no, 1, 1, 2, 3, 5, 8, 13, 21, 29, and so on and so forth. that stuff. And then the other stuff is like, probability. You have a deck of cards, it's like probability. If you have a deck of cards, what's the chance that you'll draw a heart and a joker? Or no, a heart and a jack. What's the probability that you draw a heart and a number card? What's the probability that the third card you draw is a bluff? This is that kind of stuff. Okay, are we okay with this? You do the power rule, and then you can take this addition and make it a product. And then you're done. Where'd the 5 come from? That is a square root. Square root. I suppose you could, I actually don't think they would, but I suppose you could distribute that square root to get x to the 3/2 power plus the square root of x. Or maybe I should do the square root of x cubed. Where did the 3 go? Oh, where did the 3 go? Okay, never mind.
Get out of here.
Where did you can't distribute then because of that 3.
He said, oh man, where did that 3 go? Oh no.
It was there the whole time. It was just being sneaky.
Oh no.
You couldn't see it until you asked about it because it was shy. All right, let's try this one. Okay, first thing we're gonna do is power rule. Make it a power rule. Ln x plus 2 squared. Then, because they are subtracted, we will make that subtraction into a division. Okay. All right, yay or no yay? Slow down, faster. Okay, all right, next one. First thing we're gonna do is the power rule, but because there's a parentheses here, I can distribute the 1/3 to the x and to the other logarithm too. Hey, where'd that cube root come from? The 1/3 power. Having something is the same as square rooting it. A third is the same as a cube root. All right, because this is addition, I can multiply them. Log base 2 of the cube root of x times the cube root of x minus 4. Which, if you want, you can put under 1 cube root. I don't know. They might make you do this in WebAssign. They might not. I don't know. Have it all under 1 cube root or cube root of x times cube root of x minus 4. This is the same thing. Either answer is fine. Okay?
Are we done?
Are we done? She says. Well, what would an example be without a nice guided practice to see if you really got it?
Oh.
Does anybody need more time to write before we do a guided practice?
I know, I just saw
The guided practices are the best.
that.
Stars all over it? Okay.
But not hearts. You can't do hearts.
Okay, I won't do a heart.
What?
No. Yeah,
Oh,
yeah, exactly.
There. All right, 1 minute.
You wanna-
Okay.
what,
Oh. Oh, I forgot that
This
existed.
is so much.
It's not that much. It's 2 steps.
Got it.
But it's like, it looks like that.
That's what I'm saying. It looks way more intimidating than it really actually is. Okay, okay. Can anyone tell me what I do first?
Well, you distribute the two to the.
That's exactly right. Distribute the 2. Ooh. There's really 2 ways you could do this, isn't it? Because you could distribute the 2. Hold on. Did you do this first? It doesn't really, okay, I said, this is what, when you said distribute the 2, I assumed you meant the 2 in front. You don't actually have to do that. You could do the other 2. You do whichever 2 you want. Don't let anyone ever tell you which 2 you have to do, okay? Never. Okay, what do I do with the other 2?
You want to climb?
Oh, yeah, that's right. That's how the Kool-Aid man would say you got the correct answer. X minus 2 and 4. Actually, I'll be honest, when I was getting ready to explain this, I did not see that 2 until just now. That spooked me. All right, now what do we do with the subtraction? Make it into a fraction. And to be honest, you actually really don't need these larger parentheses out in front. You can have them there, you cannot have them there, it doesn't matter. That answer is fine, or I like putting them there. And then you're done. That's it. All right, it is 12:03. You get out of class at 12:50. So you have 47 minutes to do, I think, like 10 homework problems, which is like 5 minutes a problem, which is way more time than you need. Absolutely nobody should leave here with homework. Next time we meet on Friday will be a quiz over 3.1, 3.2, and 3.3. Hi, I suppose.